Asteroid impact. Is it the end of life on Earth? Don't forget to like the video, subscribe to the channel and share so that more people can follow this content. History of asteroid impacts on Earth. Throughout history, the Earth has been hit by several asteroids, some of them with catastrophic consequences. One of the most famous examples is the impact that occurred about 66 million years ago, which led to the extinction of dinosaurs. These events are relatively rare in terms of human scales, but on a geological timeline, they occur with considerable frequency. Geological studies reveal craters around the world, evidence of the impacts that shaped the history of the planet. Scientists estimate that small asteroids reach the Earth almost daily, but most of them disintegrate when entering the atmosphere without causing significant damage. However, the major impacts, such as what happened in Chicxulub, Mexico, are devastating and can change the course of evolution. Impacts of this size alter integer ecosystems and can cause glacial ages or long periods of global warming, depending on its magnitude. The study of old craters and minerals formed under high pressures allows scientists to calculate the size and speed of asteroids that have hit the Earth in the past. This information is crucial to predicting future impacts and trying to mitigate its effects. In short, the history of astral collisions with our planet reminds us of our vulnerability to the forces of the universe. Analysis of these events not only helps us understand the past, but also prepares us to face similar threats in the future. Although it is unlikely that a major impact will occur in the coming centuries, Earth remains vulnerable, and the study of these historical events is essential to our protection. Don't forget to subscribe to the channel and share this video with your friends to stay on top of more fascinating themes. Immediate consequences of a large impact. If a large asteroid hit Earth today, the consequences would be instant and devastating. The initial impact would have a massive explosion, releasing a colossal amount of energy, equivalent to thousands of atomic bombs detonating at the same time. The impact area would be completely destroyed, with everything around it being vaporized or reduced to rubble. Shortly after the impact, shock waves would spread throughout the Earth, generating unprecedented magnitudes earthquakes and tsunamis that would devastate coastal areas thousands of kilometers away. The air around the impact would be heated at such high temperatures that whole forests could catch fire instantly, generating uncontrollable storms of fire. Another immediate effect would be the ejection of large amounts of dust and debris in the atmosphere. This dust would block sunlight, plunging the planet into a kind of nuclear winter. The global temperature would drop dramatically, causing faults in agricultural harvests and widespread hunger. The prolonged darkness would also interrupt photosynthesis, which would have a direct impact on the food chain. In addition, toxic gases released by impact, such as sulfur and carbon dioxide, could contaminate the atmosphere and oceans, making various regions of the planet uninhabitable. The consequences of this catastrophic event would not only be places, they would affect the whole globe, generating a domino effect that would change climate, biodiversity, and human life as we know. These immediate impacts are only the beginning of a catastrophic scenario that could last for years or even decades. In the long run, the consequences of an impact of this magnitude could threaten the survival of numerous species, including ours. Subscribe to the channel and share this video to ensure that more people have access to this amazing content. Drastic climate change caused by the impact. After an impact of large asteroid, the climate of the Earth would undergo drastic and almost immediate changes. The ejection of huge amounts of dust and debris for the atmosphere would block sunlight, creating what scientists call impact winter or nuclear winter. This period of global darkness could last months or even years, depending on the magnitude of the impact. With the reduction of sunlight, the global temperature would drop rapidly, leading to a kind of glacial era. Agricultural harvests would be devastated, as plants could not perform the photosynthesis properly. This would generate a global food crisis, with food shortages affecting both humans and animals. In addition, the impact would release large amounts of gases in the atmosphere, such as sulfur dioxide, which would combine with the humidity of the air to form acid rain. This corrosive precipitation would affect ecosystems, killing plants and animals and poisoning sources of drinking water. The oceans would also suffer, with a significant increase in acidification, impairing marine life and causing the collapse of aquatic food networks. When dust finally nodded, a new problem would arise: the greenhouse effect. Carbon dioxide and other gases released by impact could cause uncontrolled global warming, with the planet entering an extreme temperature cycle. After the freezing period, the warming could be so severe that it would melt glaciers, raising the level of the sea and causing flooding in coastal areas. These extreme climate change could last centuries, permanently affecting the natural habitats and geography of the planet. Biodiversity would be drastically reduced, and many species could not adapt to new conditions, leading to mass extinction. Remember to subscribe to the channel and share this video so that more people have access to valuable information like this. Mass extinctions, a possible scenario? An impact of large-scale asteroid does not only affect the physical environment, but also life on the planet. One of the biggest fears is the possibility of mass extinction, similar to that occurred at the Chicxulub event, which led to the extinction of dinosaurs and more than 75% of species on Earth. This type of catastrophic event can eliminate entire species in a matter of months or years. Shortly after the impact, many life forms would be instantly exterminated in the collision zone. However, long-term effects, such as impact winter, which blocks sunlight, would have devastating consequences for species around the world. With interrupted photosynthesis, many plants would die, and without them, herbivorous animals and eventually the carnivores who depend on them would also succumb. The food chain would collapse, starting with the simplest organisms until they reach the top predators, including humans. In addition, marine ecosystems would be drastically affected by the acidification of the oceans, leading to the extinction of numerous aquatic species. The loss of biodiversity would be one of the main legacies of this impact, with integer ecosystems disappearing. Another extinction factor would be the toxicity of the post-impact environment. The release of sulfur and other toxic chemical compounds in the atmosphere and in the oceans would create inhospitable conditions for many life forms. This could cause a waterfall of biological events that would result in the collapse of several species that could not adapt to new conditions. Mass extinctions are not immediate events. They can last thousands of years, with species slowly disappearing as the effects of impact continue to manifest. However, in such a severe scenario, few life forms would have the ability to survive, and biodiversity recovery would take millions of years. Enjoy the video, subscribe to the channel and share with your friends to always be on top of new content. Global preparations to avoid an impact of asteroid. Faced with the potential threat of an asteroid impact, several global initiatives are underway to prevent this type of disaster. Governments, scientists, and space agencies worldwide have worked together to monitor space in search of asteroids that can represent a threat to Earth. One of the main surveillance programs is the Object Monitoring System, NEO, which tracks thousands of space objects. Constant surveillance is the first step to ensure that we have time to react to any imminent threat. Agencies such as NASA and ESA, European Space Agency, invest heavily in the development of technologies that can detect hazardous asteroids with years or even decades in advance. This would allow humanity to have enough time to plan an answer. International cooperation is also fundamental. In 2014, the International Asteroid Warning Network was created, an alliance of countries and organizations that share information on objects near Earth. This type of collaboration increases the global response capacity, ensuring that if something is detected, measurements are taken quickly. In addition to surveillance, there are global exercises and simulations to train response teams. These exercises prepare nations for situations where it would be necessary to evacuate areas or take other emergency measures if an impact is inevitable. The exchange of knowledge and the creation of emergency protocols can make a difference between life and death in a crisis situation. Asteroid impact prevention is an issue that goes beyond a single country. It requires global cooperation, continuous technological development, and active surveillance of space. It is this preparation that can guarantee the survival of civilization in a scenario of impact. Be sure to share this video with your friends and subscribe to the channel for more interesting content. Technologies and missions to deflect asteroids. Humanity has already begun to develop technologies and plan missions that can divert asteroids on a collision route with the Earth. One of the most promising approaches is the kinetic impact technique, which consists of launching a space probe against the asteroid to change its trajectory. This method recently gained prominence with NASA's Double Asteroid Redirection Test (DART) mission, which performed its first test in 2022. The DART mission was a historic milestone. The spacecraft intentionally collided with an asteroid named Dimorphos, proving that it is possible to change the course of a dangerous celestial body. This successful test has paved the way for future missions that can use this technique to protect the land from real threats. Another strategy under study is the use of nuclear explosions near the asteroid surface. Unlike Hollywood movies often show, the idea is not to destroy the asteroid, but to use the strength of the explosion to change its direction. However, this approach is more controversial due to the risks associated with nuclear detonation and the difficulty of controlling asteroid fragmentation. There are also proposals for the use of gravitational tractors, involving the placement of a ship beside the asteroid. The gravitational attraction between the object and the ship can over time change the orbit of the asteroid. Although it is a slower solution, it avoids the risk of fragmenting the asteroid, which could create new problems. Another study technique is the use of lasers or solar mirrors to vaporize the asteroid's surface. This process would generate gas jets that, over time, could change their route. Although this technology is still in an experimental stage, it has an interesting option for the future. These missions and technologies show that humanity is progressing to protect itself from spatial threats. However, the success of these initiatives depends on constant surveillance and continuous investments in research and development. Subscribe to the channel and share this video to ensure that more people can learn about this fascinating theme. Possible solutions to survive the impact of an asteroid. Although the focus is mainly on avoiding an impact, scientists also consider scenarios in which the collision would be inevitable. In this case, it would be necessary to think of solutions to survive the catastrophic consequences of an asteroid impact. Preparation and quick response could make all the difference. One of the first measures would be the mass evacuation of the areas closest to the impact. Countries around the world would need to mobilize their resources to relocate millions of people to safe areas. This operation would require international coordination, with evacuation routes and global-scale shelters. However, this is a challenging task, considering the magnitude of a disaster of this proportion. Another crucial point would be the creation of underground refuges. These shelters would be essential to protect people from immediate effects, such as waves of shock, thermal radiation, and atmospheric debris. Several countries have already begun to invest in underground shelter technologies capable of supporting natural and artificial disasters, but their capacity would be limited to a small fraction of the global population. In the long run, food self-sufficiency would be a challenge. With agriculture devastated by an impact winter, nations would have to develop ways to produce food under extreme conditions, such as underground greenhouses or using hydroponic and airplace cultivation technologies. Food storage and drinking water in large quantities would also be vital for survival in a post-impact scenario. In addition, the impact on energy and communication networks would be severe. To survive in a hostile environment, it would be necessary to have renewable and decentralized energy sources such as solar and wind energy in protected places. The reconstruction of vital infrastructure would also require years of work and global cooperation. Finally, Social resilience would be as important as physical preparations. Maintaining order and social cohesion in the face of a planetary catastrophe would be essential to ensure that communities work together to survive and rebuild. The creation of emergency plans, combined with a well-informed population, would be the key to increasing the chances of survival.